V1. Right. So that means delta P, which is equal to what element of M into V2 value, we have it 0 minus initial velocity U. Now, so that means change in momentum, which is equal to what element of minus M into U na. Here, this is the momentum for in case of one ball, but they given n balls. They are saying now due to n balls, what I can say now here, momentum because of n balls, we should multiply the number of balls, n into m into u. This is the change in momentum for in case of n balls. So from this, we can write now finally F is equal to what element of change in momentum? Delta P by delta T. So that is given as F is equal to minus N M U by delta T, which is given as 1. So we'll get the momentum. So force which will be equal to M in C is N minus N M U. This is the force experienced by the surface. This is material questions. You have material. Give me material. The minus and the mu. The minus indicate what has been direction. Okay, that negative sign means that is a directions only. Yeah. Done. Take the next problem. No. The students. It's such a yes, positive exact.
The question was given one bracket is here, one is going with it, it's coming back with the same screen. It's time to give the contact. What should we find out?
So 8.4 we need to find. So now what? So it with what velocity?
So velocity and time given by an acceleration machine.
Look at now. Yeah. So with what velocity the ball hitting the rocket?
60 meters.
Okay, that is V1. Next, with what velocity going back? Yes, that means we can find the going back minus 60 will take now. Here. So what is the acceleration? Tell me.
60 by 0.0.
So this is 60. No. What is the V is equal to U plus CT. Yeah, so if we have directly we can do this formula. What is the formula here? F is equal to, what is the formula we have to use now? Yes, dP by dt. What the P is a momentum. So we can write it as what element of delta P by delta T we can write now. What is the delta P? Tell me now. Delta P, which we can say this as M into what we can say now. Yes, V2 minus V1 a change in velocity. M into delta V. And how much the V1 value? Tell me.
60.
Yes, so 60 meters per second, right? And V2 value how much? And they given, this is the x direction given clearly. So that's why we'll take it as a I cap we can take. So they given along positive x direction. Here options contains the direction of force is also there now. Positive x, negative x is there now. If not given, we need only magnitude only, but directions also given, we should take it as vector form. Next, V2 is how much? Yes, minus 60. So minus 60 I cap. Now, so here delta P is how much now? Mass. Mass is given how much? 50 grams given na? Mass 50 grams means, yes, 50 into 10 power minus 3 into what tell me now? V2 minus V1 means what tell me now? Minus 60 I cap. Minus 60 I cap now tell me. So how much will come the delta P now? And which is equal to 50 into 10 power. So this V2 value negative. V2 value how much? Negative, but minus is there here. So that is minus 3 into this will come minus 120 I cap. Now, how much will come? So we'll get the delta P. So this value which we can write it as minus. So this is, we can, so this is 5 into 2 zeros will get cancelled now. So this is 60. 3 zeros will get cancelled. How much now? 6 minus 6 I cap now check it. Now, so force means what? Tell me now. That is delta P by delta T. So delta P we got, that is minus 6 into I cap by delta T. Time is given. So that means 2 into 10 power minus 2. So which will come to be what? Tell me now. 0.02 na seconds. So this value that is minus 300 into I cap. Now tell me the answer. What is the option now? Force na. Force means newtons.
300 Newton minus x direction.
Negative x direction. So what's the option here? That is option 2. Okay.
Friends, send this note, sir.
Ah, we share. Without sending the after completion of each chapter and share, then you will keep like that properly. So daily, if you want, I will share the daily class notes also. Ah, that's right. So if I chapter wise, you will keep, I will say the notes. That's right. The same file we are doing everything. I'll share after completion of each chapter. I will share. Next. He pushes with a force of one block. P pushes with a force of 500 newtons and Q pushes with a force of 300 newtons. Okay. Okay. Frictional force provides. Okay. Frictional force. Okay. Friction force means you just remember that is nothing but opposition. Opposition for the movement of the body. So if the body moving one direction, it will the frictional force is the opposite direction. If friction force provides 200 newtons of resistance, what is the acceleration of the train? Uh, yes, we can treat as simply as a exactly. That only there. So here, this is a one crate. This is some block we can consider. So this block mass is given how much? So this is given as 1200 kg. Here, this lies on a surface. Yes. Now what they're saying P and Q and yes, pushes same direction or opposite direction? Same direction. So the two person imagine now this P pushes like this and Q pushes also like this only, same direction. Now what happens now here? P given for Q given. So and what else now there is an opposition is there now? So resistance force means opposition. So if I push now, this block will try to move this direction. Right. Now there is a friction is there. What the friction will do? Will opposite direction will create the force. And the friction, so between always between two contact bodies. Now here this one, this table and this one. Here we have applied some force now here. And the friction is between these two book and the table. Yeah, this friction will causes opposition this direction. So the block try to move right side. The friction is which direction now? Left side. Right. So what is the acceleration means? What tell me now? Net force by total mass na? Will place. Net force by total mass. Now we'll place this term here. Net force is what tell me now? So PQ forces are along acceleration, that's why positive. And the frictional force is opposite direction, also it is negative. So means P force is how much now? 500. And Q force is how much now? 300. And frictional force is how much now? So this is opposite direction, also that's why negative. By mass is how much now? 1200. So find the acceleration now. 5 ऑप्शन नहीं है 5 है 0.5 yes 0.5 so this is 600 by 1200 yeah right next problem normal means perpendicular Mm. So what they're saying here is small, so we have to run the ball. Mm. 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 Why minus?
Change in momentum.
Mm. But it should be we have to see the directions also. So this is now change in momentum we need to find. Change in momentum is delta P na. So that should be equal to what? Tell me now M into delta V. Tell me now here. What is the V1 tell me initial velocity? So you have to be careful now here. So let us say this is the wall we'll consider. Now here is a ball now initially a ball which is moving like this. Now if I call this is the initial velocity V1. How much the initial velocity given now U into we can take it as I cap cos to x directions. After hitting, what happens now here? Rebounds with a velocity v. Rebound means going back. And it is going back to with a velocity v2. Tell me now how much is v2, which is given as v. And the direction is what? Tell me now. Minus v into I cap na. Right. So now you can see now we'll find the change in momentum now. So tell me now change in momentum from this. So this delta P, which is equal to M into what? Tell me now. V2 minus V1 na? Yes, V2 minus V1. So will come to be a. That is M into V2 value. What? Tell me now. Minus V into I cap minus U into I cap. Now will come to be a what? Tell me now. Delta P. So this we can say minus common, that is M into we can write as B minus or minus plus minus common into what you tell me now I cap. So this means momentum delta P, how much the magnitude if we say this is M into V plus U. And the direction is what direction now? Minus I. Minus I means what? Tell me now. Away or towards? Away. So that's why what's the option? Option 3. This one? Hmm. All types of problems we have to see. Force is given, momentum is given. T value delta T we have to find.
He only gave us 125.
Hmm.
Delta T I got 1 by 2 square.
Option
0.5.
0.5 seconds. So that is F, which will be equal to delta P by delta T. So we need to get delta T only now, and which will be equal to what? Tell me now. Delta P by F. So that is how much the delta P value they given? 125 by 250. So that means delta T will come to be a 1 by 2, which is how much now? 0.5 seconds. Nice.
Equals to delta P by delta T.
They
Delta T is equal to delta V by delta T.
right, we should talk about number of bullets. We can take n also. N into delta P by delta T. N value we have to find. That is n by T we need to find. They ask to find number of bullets per second. N by T we should find per second.
Delta V by delta T. Forty grams of the converted into kilometers.
No, always a system. Delta P by delta T.
3 amps.
So this we can. So this is F is equal to We'll write it as n into n by t into, we can say this as a p. Right. How much is momentum? Tell me now. Momentum, we can write a m into v, will write now. So this is n by t into m into v. So f value given us how much now? 144, and which will be equal to n by t. Mass given as 40 into 10 power minus 3, and velocity given as 1200. T. So we need to find the n by t value. We should find 3 zeros will get cancelled now. So this is n by t, which will come to be a what, tell me now? 144 by 48 now. So this is n by t, number of bullets per second, which will be a 3. Right. Next one.
And chemical unit is what?
That means dm by d. Yes, the kg means what will be mass. By denominator time now, that means dm by dt. They given the kg per minute. We should convert it to kg per second. We should require. We need to find the force. We need to find. So here, so basically Newton's second law, F is equal to dp by dt. Right. So here we'll write it as what we tell me now. What they're saying here. Look at now here. They're saying the force required to maintain the motion with a constant velocity.
T delta V by delta.
So in this case, velocity constant. Okay, velocity must be constant. So there is no delta V na. So this means mass dm by dt will write now.
dm by dt into V.
Yes. So this means now this force which will be given as what will be now basically dp by dt, and here this we can write as p is equal to m into v na. Then here v constant, so we should apply the derivative to only m only. So this means we can write it as what, tell me now here, this is dm by dt into v. We should maintain a constant velocity. We should maintain velocity is always constant. Right. Now you can tell me now here dm by dt. Here they given this as dm by dt. How much given? They given as a 10. This is given as kg by minute is given. We need to convert it kg by second. Minute is not SI system now. So we'll write it as what, tell me now, 10. This is kg. And 1 minute means 60 seconds now. We'll write it as 60 seconds will place. Then it will be equal to what I can say now here, 1 by 6. Now I can write it as a kg per second I will write. Now we'll place this value here to get the force. Now get the force now here. dm by dt is 1 by 6 And velocity we should maintain constant. They given at 10. Huh? Speed velocity only. Okay, so that means how much this value, tell me now here? 5 by 3 now. 5 by 3 newtons. They will give you to confuse. Unnecessary data also there. Should able to identify which is unnecessary. Next. Exact speed means going speed. It has to go. Yeah, initial speed you can. Yes, dm by dt we need to find. Right. So look at now what we can do here. So basically this rocket, right. Now 5000 kg rocket is set for vertical firing. Now, so with what speed has to flow here? 800. So initially it has to move upwards with how much acceleration has to go? This much acceleration. And so A that is given. So weight of this one is what direction? Tell me now. Downward direction. That is how much you tell me now? mc. Okay. Now this rocket should have certain amount of, this is thrust. Which direction? Upward directions. So this is a thrust force, means the one which will pushes the upward direction. That force is called as a thrust. How much will be the thrust? We need to find out now here. Yeah, look at now here. So we'll write the equation now. Acceleration, which will be equal to what? Tell me now. Net force by total mass. Acceleration equal to net force. That means thrust minus mg by total mass, isn't it? So how much is the thrust now? So we can find the thrust required, which will be equal to what? Tell me now. This is m into g plus a. Cross multiply, take the mg to other side. M into g plus a. So for the rocket launching, so this much of thrust is required. This much of force, the rocket has to start flow. Right, fine. And to, so for the flowing of this rocket this much, we need to do something. So that means that's why only we have the rocket. When you're moving payloads, we used to call. After moving here, so the payload, they will burn. So then when it is burned, so that will give the energy to the rocket. After going some height, they will ask to burn one more. They will make one more to burn payloads. That energy, when the heat energy released, that energy will be converted to mechanical energy. Then rocket is pushed. Right. Those are called as a payloads. Now this much of force is required. And basically the force required, that should be equal to what? Tell me now here. It should be equal to dp by dt na. Here, this it has to move constant speed, has to move. Here mass is variable. So that means when the rocket initially, which is full of it, yeah, 10 payloads or 20 payloads will contain. After moving some, let us say 10 kilometers, one payload will burst. Then the mass will decrease. After some distance, some other payload. Like this goes on, the mass will decrease, isn't it? With what rate the mass has to exhaust. So that we need to find. That is what we can say now. This is dm by dt into v na. Here we need to find dm by dt. We need to find. Yeah, velocity given na. So F means F thrust force only. That is M into what you tell me now? G plus A, which is equal to dm by dt into V. Now velocity also given. We can substitute all the parameters. Now mass given as how much you tell me now? 500, sorry, 5,000. And G value 10. Acceleration how much now? 20. And which is equal to dm by dt, we need to find dm by dt into v. Velocity is how much now? 800. So from this we need to get the dm by dt. Will come this as 5,000 into 30 by 800. Now these two zeros will get cancelled. So this is 2 fourths now, this 225s. So here 75. So this is how much now? 750 by 4 now. How much will come?
187.4.
187.4. Okay. Like this point, it is near to that.
3.
Yes, 187.5 now. So this is kg per second. 4 after the digit is more than 5, we'll add the 1 will be added now according to significant figures, rounding up. Yes. Collides with a smooth wall and return with a velocity of the impulse. Impulse is nothing but change in momentum.
Delta P we have to find out. Delta P you.
Yes, final velocity minus initial velocity. That's it. Impulse means change in momentum. Impulse is nothing but change in momentum. M is constant. Same body they are saying. Now, initial velocity, final velocity. Identify which is the initial velocity, which is the final velocity. A small sphere moving with this much of velocity. That is what velocity it is moving. Before collision is the initial velocity. After collision, final velocity. Impulse will indicate I letter. Right. So this means impulse, which is equal to mass, is given to V2. Final velocity na minus I plus 3J. Initial velocity minus 4I plus 7J. Then how much is I value? 2 into, that is minus 5I cap plus 10J cap. Minus na, see that signs properly. Right, 2 into this is, we'll find the magnitude now here. So this is 5 square plus 10 square. So this I value, which will come to be a 2 into 25 plus 100. So this I value will come to be a 2 into root 125. 125. So 25 into 5 will write now. 25 root means 5. 5 will come outside. 5 into 2, 10. So this will come to be how much now? 10 root 5. Kg, same as momentum units. Kg meter per second. Next one.
Wait, like we said, keeps one physics lecture comes in college. So we have 10th, 11th, and 12th. It's like a rapid fire question. It's the last question. Students are prepared to answer.
Okay.
Some theory questions, some numericals.
Okay.
And smart parts are yours. Around that, one not the steps of the song and but not the lengthy steps also. That's the 10th, 11th.
So in those cases, they will ask the not question, theoretical question they will ask. Yeah, so. PV questions now they will ask. Okay. is thrown at an angle theta with the horizontal with the initial velocity u. The change in its momentum during its flight means time of flight. So in a time interval of t. So means projected. We collect a projectile situation. So when we have time of flight, when you have projected, this body reaches here now. Yes, at this location we have, if we remember, this velocity and this velocity which is v1, initial velocity. And when it is reaches to the funnel now here, and this velocity which is v2 now, if we could have remembered, so this angle which is equal to theta. And what is the velocity v1 will write, tell me now? v1. So which will be equal to what? Resolve now? Yes, along this direction, x direction, y direction. How we can write now? Yes, u cos theta into I cap. Yes, plus u sin theta j cap. Remember this thing. When the body reaches at the highest point and at the striking point, this point O we have taken, this point is A, and at this point B. Tell me now, at the point B, what is the velocity?
0.
No, at the highest point, vertical velocity 0. At the point B, velocity same as initial velocity, but what happens now? X direction velocity remains same only. Y direction velocity also same, but opposite direction. Here, this component, how we can resolve now? This direction we can resolve now. So this is now one ux, and we'll write it as a uy will write. And at this location, what tell me now here? This is, so this is ux, and but this is what direction, tell me now? Yes, negative y direction. Because of that, what is the velocity at this location will come, tell me now? X direction velocity, both magnitude and direction also same. Y direction case, magnitude is same, but direction is opposite direction. Okay, so that means V2 value will come it as what, tell me now? U cos theta into I cap minus U sin theta into J cap. Remember this thing. Now we need to find what, tell me now here? Change in momentum के लिए change in velocity required ना delta V. Change in momentum means change in velocity delta V. Find out the delta V, how much will come?
Sin theta
So this means will come delta V, change in moment, delta P we need to find. So this is minus 2u sin theta into j cap. So we need the delta P na, change in the momentum. So that is which is equal to m into delta V, which will come to be a minus 2m 2m u sin theta into what will be now j cap. Wrong completely. Right?
Can I say this? That you answer. You answer.
What do you find?
Nobody can remember. Sorry, wait.
Okay. Done. Next. An object of mass 3 kg is at rest. So here 3 velocity we need to find now. So force given. If we know the force now here, we'll find the acceleration. Delta V will find. Yes. Now here, but here they are asking to find what element now velocity of the object at t is equal to 3 seconds, not at t is equal to 0. Okay, then what we can consider now here? So delta p by delta t. Yes. T value we can place. Yes. F is equal to, so that is m into delta v by delta t. Now this I can do simply as what I'll be now m into delta v by delta t. I can simply write a. So can I get the acceleration now? So will be nothing but f by m na. F value we know, m value we know. So that is 6t square into I cap plus 2t into j cap by mass, which is equal to 3. So we'll get the acceleration now. That is 2t square into I plus 2 by 3 t into j na. This is what tell me now? Acceleration. So we need to find the velocity at t is equal to 3 seconds. And they are saying that initially the body is at rest now. That means initial velocity is 0. Then we can write the velocity, we can find final velocity formula. V is equal to u plus at. So then we can say now v, which will be initial velocity. T value given as 3 seconds. A values. Here only we can find. Yeah, then A value will look, put the T value here in this case. That is 2 into 3 value 9, 9i plus this is 2 by 3 into 3 into j. So we can find A is equal to this is 18i plus 2j. This value we can place now A plus. So A is equal to how much now? So the option is not matching, I'm saying. So this is 18i plus 2j into 3 na. Into 3 also there na. But no. Yeah, we'll multiply, we'll get something else will come na. In F into P. Okay. Here, small thing more. Okay. Here the problem is, okay, I'll tell you this thing. Here the thing is velocity. So here we are using the impulse. We have seen just now impulse, which will be equal to m into v minus u. Impulse means what? Tell me now. Impulse, we have one more formula we have. This is impulse, that is given as integral of f into t, f into dt. So the area of the force, if I integrate now, we'll get the impulse will come. Okay. So this is, now we'll find the impulse from this now here. That is integral of f value, how much given now? This is 6t square into I plus 2t into j. So this is 0 to 3. We can find the impulse from this now. I value, which is equal to 6 into what? Tell me now. T cube by 3 integration. T square integration into I cap plus this is 2 into t integration, again t square by 2, and thereafter we need to put the limits. Yeah, integration means integrate, increase, power increase. Differentiation means decrease, power decrease. Here this force is a depending on time, so that's why we should do integration method. Now how much we'll get now here is I value. So this cancel now here. This is 2. So 2 into, we have, will come 3 cube now. So that is 27. 27i plus this is 2 cancel and this is j. that is 9j. Okay. T square means 3 square. 3 square is 9. 2 cancel na. Now this is what tell me now here. We got this impulse. So this is 54 na. 54i plus 9j. Now this is impulse now. Now what we need to find now here? Impulse velocity we need to find. So the impulse formula is what tell me now? That is m into v minus u na. So that we got it as how much now? 54i plus 9j. So mass we have a 3. Final velocity we need. Initial velocity 0. Yes, that is 54i plus 9j. That means v is equal to what element of 54i plus 9j by 3. So how much will come here? 18i plus 3j. So this is the option. Here the thing is force is a function of time, so that's why we have to do integration method in this case. Next. Density means mass by length. The given what type of density is a linear density. That means mass by length is called as the linear density. Lying lengthwise on a smooth horizontal floor. It is pulled by a force of 25 newtons. The tension in the rope at a point 6 meters away from the point of applications. Okay. Now, so this type of problem we have seen. Yeah, look at now here. They given length of this rod is given, rope is given as how much now? 10 meters. And the density is how much now? There's the density. Density will denote as mass density, linear mass density, lambda. That means what tell me now? Linear mass density means what tell me now? Mass by length is called as a linear mass density. And which they given us what tell me now? 0.5 kg by meter. The linear mass density given like this. Okay. Now, so they are saying it as what tell me now? We need the tension we need to find. So look at now where I need the tension now. Where I need tension now here. So initially this is a rope. And this the complete length of this rope is how much they given? The length is given as a 10 meters. Now, so this it will lies on a, so now how much the force is applied, you tell me now. This is the 25 newtons of force we apply. Now they are asking to find what, tell me now here. Find the tension in the rope at a point 6 meters away from the point of application. That means if I say this, at this point we apply the force now 6 meters away. That means somewhere here maybe now. At this point, they ask him to find the tension. Right. So what I should do here, this part will have certain mass na. If I call this as A to B and this is C. Now this is mass is M2. So that look at now here, AC will have a mass M2, BC will have a mass of M1. Right. Now I will treat this as a combination of two blocks. I can treat now like this. This is one block. This is the other block. These two blocks are connected by a mass. Huh? Yes, the whole thing AC is having mass now. That mass I'm treating as a block. And this will have a mass is M2. This mass is M1. This type of problem we did earlier, if you remember. This type of problem we did not. Now they are asking to find the tension here. Remember this type of problem? Now, how much the mass of M1 you tell me now? So this is, that means 0.5 kg per meter. 1 meter will have a 0.5 kg. That means M1 has how many meters? See that one, what they are asking. 6 meters now they given, not a midpoint now. So they are asking to find what element of midpoint. They are not asking, they are asking some location now. 6 meters away from the point of application of force. That means from here to here, this is how much length is a 6 meters. For 1 meter 0.5, 6 meters how much mass? Yes, so that is how much is M1 value? 6 into 0.5, that is 3 kg. So this M2 value, M2, this AC length is how much now? 4. 4 into 0.5, that is how much? 2 kg. So instead of giving directly mass, they given the mass density like this. From that we need to find the mass we'll find. Now can you find the acceleration of the system now? How much? Yeah. So what is the acceleration now? So this acceleration A, which is equal to net force by total mass. How much the acceleration? Acceleration means what? Net force by total mass. How much the total mass? How much the net force we applied? So this is net force is 25 now. By total mass is how much now? 5. So how much the acceleration? 5 meter per second square we got. Now, so you tell me now here, I told you now. Now, so here we apply the force. Now this fellow will takes. How much the force taken by this fellow? M into A. 5 into 3. So that is how much now? 15 will be taken by this fellow. Remaining will be given to here now other end. So how much the T value now? Yes, how much we applied? How much I applied? 25 we applied. And this fellow will take. Then our kitna bachega? So that is. So here, अगर मान लिए, so here your father bring one sweets. Now what you do is, now here so when the father bring the 25 sweets, then you will eat the all 15 sweets, and the remaining 10 will be given to your brother. That's what. So here 25 given, applied. That fellow will take, first fellow will take how much? M into A. That fellow will take it as 15, and remaining will be passed to the next fellow. Right. Next. This type of problem we did, you need to answer. Answer this one. So many problems we did on this thing. 2 blocks, 3 blocks we did. How much the force we applied for this thing? So then what is the acceleration of the system?
Problem which side is opposed to?
See the arrow, na? See the arrow is which direction? The direction only. Much. How much the acceleration? Tell me how much? Much. How much the force you applied, yeah? Then acceleration formula, net force by total mass, now then what are you thinking? Total mass is how much? Then acceleration formula, net force by total mass. What you are thinking? How many problems we solved? Yeah. Acceleration is how much? I'm asking. Acceleration formula is what, yeah? What is the acceleration formula? Net force by total mass, na? How much the total mass? Then how much the value? What are you thinking then? How much the net force value? How much the force you applied here for this one? Put the values, then what are you thinking? What 20, yeah? 40 by 20, 20.
2.
This is 40 by total mass is how much? Then how much is acceleration now? 2. Acceleration 2. Now you tell me now here. Now we have, so then with a 2 acceleration, it will move now. Now you tell me how much this fellow will take.
10, 20.
This fellow M3 block. 8 newtons will be taken by this fellow. Then how much left out now here after this block? Yes, the total we applied it as 40 now. 40 you applied. Now this fellow will take 8. Then how much left out for T2 now after this block? 40 minus 8. How much? 32. Now how much for T1, tell me here? If they're asking for T1, if they're asking, then how much the T1 now here? So you at this location we have a 32.
20.
Yes, 32. Now this fellow will take M2 will take how much now? 12 will take. Yes, this fellow will take 12 now. So that means how much this value T1 is a 20 newtons. So here asking the T2 now. So the answer is 30. Next. Here first masses of blocks given. What else given?
Force. No, force is not.
Force not given. What given? Acceleration given. From that we'll find the force now. Find the force now first.
Eighteen force.
Yes, same procedure. Yes. So you applied the net force. How much the force we applied? 80 newtons we applied. Okay. Next. Now acceleration we know now. So that means here we apply the force here now. How much this pillar will take? How much force this pillar will take? Yes, the 12 newtons will be taken by this pillow. Then how much is left out now here for the second block? 6 newtons. So that means 6 newtons will be left. Now look at now here. 6 newtons. Now you see this thing. Which direction? Here they are asking to find the force on way to where. They are asking the force B on A. How much force Right. So here we have the blocks are there side by side. So you applied some force now here. This block try to move like this, but this block will oppose us to this block. Means this block apply the force on this block. At the same time, this also will apply the force on this, isn't it? So now what they asking to find? How much the B block will cause the force on A block? So yes, now jitna A block will causes on B block and utna B also cause on A. But so here A will cause us this direction and B causes this direction. Okay, so that means how much the force now 6 newtons, and we need to see the direction of which direction the force will happens. Now here B causes on A, that means B pushes A to this direction. Now A pushes the left right side, B pushes left side. That means which direction you tell me now here? 6 newtons to the left. So option 3. That wording terminology important wording. So which direction? A on B or B on A? Then next. Reading is nothing but tension. Tension, that is the spring balance. In the middle, they connected spring balance, they connected. We need to find the tension, we need to find. And for the tension, we remove the G value. First, find the acceleration of the system. Here they given. So this weight, which is what we can say now, M2G, and this weight is M1G. Here, whose weight is more? M1 is more, so M1G is more. So that means this block will move this direction now with an acceleration A, and this block will move upward direction. Now find the acceleration now. So remember the acceleration formula, net force by total mass. Tell me now here. So that means along acceleration force taken as positive. Opposite to acceleration, negative. No, T should not be taken. T is the internal force. So weights only causes the motion of a body. Na? While finding acceleration, keep in mind tension, don't consider always. Keep in mind. Yes, so that is what we can say. Yes, M1G minus M2G by M1 plus M2. This is the acceleration. Now we'll get the tension we should find now here. So we'll write the acceleration equation. Will write now. Tell me. A is equals to yes. M1G minus T1 by M1. So from this we'll get the T1 value. So if we cross multiply, how much the T1 value will come here? M1 into, we can say now, G plus A. G minus A, G plus A, G minus A, I think. Yes, G minus A, na? Find the T1 values. A value we put then. Options are not there now, so we have to get. So A value we got, now A value put in there. We need to further simplify.
G F1 F2 M1 by M2.
Yes.
G.
That is a tension. So spring balance. Spring balance will measure the mass only, na? G. So divide with the G. Only mass. So when you, yes, so then simplify now here. It will come to be what? Tell me now here. 2M1 M2 G by M1 plus M2 will come now. Right then. So then let us say you want to measure your weight. And mass will measure. So whatever you used to say, that is what? Tell me now, mass or weight? So that is what? Tell me now, but that is actually, so that is the mass only will measure. Whatever you used to say, used to measure, it is what? Tell me now, mass of your body, not weight. Mass only it will measure. So then it will measure the total weight they will measure. They will divide the value with the 9.8 and finally will display. So then here spring balance. So spring balance reading is how much we can say finally? That's what we used to say in our kgs. So here, so when you are measuring this as a 1 kg, 2 kg, 3 kg will say now. Here we are taking the some apples you are taken. They're measured. But what it will measure now, initially tension they will measure. That means force they will measure. After that, they will divide with the 9.8. And then finally they will give the value mass they will give. So what you will say now, your weight is 50 kg, 40 kg, you say that 50 newtons, 100 newtons will say. Weight means newtons, na? Kg, that means mass, whatever we used to say, but we used to call the weight of a body, we used to say. It will measure the mass. Two masses are attached to the ends of a light inextensible string, and string is made pass over the surface of a smooth fixed pulley. When the masses are released at rest, acceleration. Same thing. Earlier they given diagram, here not given the diagram. That's it. So they are saying it as a pulley. So here this masses they given. And see the masses now here. This side which we have this as capital M plus small m. And this side is what now capital M minus small m. They ask you to find the acceleration. Yeah, do it. The same procedure. Now here this block is mass is more now, so this block will move down. This weight is how much now? M plus small m into G. And this weight M minus small m into G. Yes, so this is downward direction and this will move upward direction. So, yeah, look at now here. In these cases, whenever we have this thing, the right formula you can remember easily. So, in this case, this type of formula here, if we call this block mass, which is equal to this block mass is M1. This is one standard formula. This is mass is M1. This mass is M2. Whenever we have the acceleration formula, which will be equal to, so this is M1 minus M2 by M1 plus M2 into G. Remember. Just that what we have seen earlier. If you see this only now look at G common we have taken, that's it. Okay, so this is the standard formula. Whenever we have two blocks are there like this, directly we can use this formula. M1 minus M2 by M1 plus M2 into G. That's it. So we hear the M1 is how much? Capital M plus small m. M2 is M minus M.
Into G.
G. So how much now?
Option A answer.
So here G is small m by capital M now.
Okay.
Next. Same problem we did already. Tell me the answer. Acceleration of 5 kg block. How much the acceleration? How much? So here, how much is weight now here? This is 50. Okay, fine. So if you want to do fine, if you do that one here, that method, yeah, tell me now A is equal to how much now? 50 minus T by 5. Now for this block, yeah, so no, here this block also will move like this only, na. So for this block acceleration is how much you tell me now?
T.
Yeah, T by 4. Equate those two simply. Then we'll get T value. Then after that we'll get acceleration.
Then option 4, 5.4.
How much the T value?
200 by 1.
That is 200 by 9.
A is equal to 50 minus 200 by 9.
Yeah, so A will directly will put here, na. So this is how much now here? 200 by 4 into 9. How much will come?
5.4.
5.4. Right. Yeah, so but here earlier we did one simple method we discussed.
Not well.
Simply. So this acceleration which will be equal to what tell me now here? Net force by total mass. So that is 50. So this is. And this acceleration of block this direction na. So these two same direction. So that's why 50. Next, but here this weight is this direction na. And 90 degree. This cos 90. 0. That's why this should not be considered now. By total mass is how much now? 9. That's it. Yeah. He also will get now here. So cancel this now here. 4 से cancel किया तो how much now? The total will come now. That's it. Okay.